We have had a mystery on our hands this week. The scholars in this room are the crew of the mighty ship the Visioneer. While in search of an ancient treasure, we are marooned on an island, and the key part of our navigational map went missing of the entire crew. We considered 4 subjects. Today you will hear the evidence collected against Dr. Smart and Shipwright Nuts.
Imagine you're in a storm and your arm is broken. You'd have to know how to help the person, so this is what you do.
A way to help someone is by using a SAM splint.
First, you have to have it to fit in the bottom. Next, you have to compliment it. And you put a sling on if you have.
We're doing this because there was a storm, and if you're ever in a situation, you'd have to know how to help so the person doesn't get more injured.
In our medicine component, we also made model lungs because one of our characters had a collapsed lung. Caleb will show you how it works.
The balloon on the bottom is a diaphragm, which is the muscle between your stomach and your chest. So then when it's pulled, it absorbs air, which comes inside your nose to your lungs. So then when you let go of the balloon, the air goes out through the straw, and that's when you breathe out.
So for the engineering part of this program, we built these little robots. They're called M-bots, but we gave them names. And we were supposed to we found First Mate Sydney Young, which we believed that she was missing because she got kidnapped by one of the crewmates on the ship.
And after the robots found Sydney Young, we programmed them to bring her back.
You can use the robots to create fun tricks. You can change the color of them, but you have to control them with an iPad, an iPod, or a phone.
The heart is critical in your body because it pumps blood and keeps you alive.
The top blue vein is called the aorta, and it pumps blood into the body.
The top red artery brings blood into the right atrium to start getting oxygenated.
After the blood goes to the right atrium, it goes into the right ventricle.
After that, the blood goes through the pulmonary vein to the lungs to get oxygenated.
Then the blood goes through the pulmonary artery to get to the left atrium.
From the left atrium, it goes to the left ventricle and gets pumped back through the aorta and into the body.
Blood goes through the body, through the veins, which makes it travel into your limbs.
The blood loses oxygen as it goes through your body, and that is why it needs to get oxygenated.
This is why the heart is important.
Getting bit by a snake is very dangerous. It is very important to know your do's and don'ts during this time. Do's during these times are to move away from where the snake bit you. Call medical services like 911 and to always remain calm. Don'ts during these times are to not drink alcohol or caffeine. Do not move around too much, else the venom will move around your body. And do not cut into the wound, as it can get infected. Now that you know your do's and don'ts, you can always stay safe at the time of a snake bite.
The types of snake on the island was the red-tailed green rat snake. It is a non-venomous and it is 7.5 feet long. The pit viper is a hemotoxic and it is 2.7 feet long. The branded carrate is a neurotoxic and can go to 6 feet long. And the king cobra, it is a neurotoxic and can reach up to 20 feet in length.
Now let's talk about the venoms themselves. You have hemotoxic venom and neurotoxic venom. We're going to be talking about neurotoxic venom first. Neurotoxic venom affects your neurons in your brain. Once you get bit, it will start circulating through your body. If it reaches your heart or brain, you're basically dead. It can cause hallucinations, numbness, and paralysis. Now, let's move on to hemotoxic venom. Hemotoxic venom affects your blood. It makes your blood thicker, so it's harder to move through your body. Once that reaches your heart or brain, you're also dead because your heart really can't pump all of that blood.
We use blood splatter analysis to find out who might have dropped blood at the crime scene. First, you measure the length of the drop of blood, and then you can use that to see how high the blood dropped from. Then you can look at the suspects and look at their injuries. If the suspect's injury matches the height that the blood dropped from, you know that they dropped the blood there.
We dropped 3 drops of blood on a piece of paper and from 3 heights. 12 inches, 30 inches, and 66 inches, and all of the heights got 3 drops of blood. We then recorded all the evidence on a chart to find the average. One thing about it is when you drop the blood from 66 inches, it will have a bigger splatter because the impact from it is more than all the others.
To find the height of the actual blood splatter, we took all of the averages for each height from every table group. We took the averages from 12 inches, 30 inches, and 66 inches, and found one big average for each height. Next, we looked at the length of the real blood drop and found which average height it was closest to.
In order to determine what the white powder at the crime scene was, we had to test 4 different powders and see how they reacted to vinegar. Powdered sugar, cornstarch, and cream of tartar didn't react, but the baking soda fizzed and bubbled. When the mystery substance was tested, it did not bubble, so we knew it wasn't baking soda.
We also tested the powders with iodine. All of them turned a caramely colored liquid, besides one. The cornstarch turned into a sticky black substance. After gathering this information, we tested the mystery powder with iodine. We figured out that it was cornstarch because when tested with iodine, it turned into that exact same sticky black substance.
Okay. At Pathways to STEM, we learned about fingerprints in our CSI component. The materials that we used were a magnifying glass, cocoa powder, a cup with fingerprints on it, and a brush.
We first dusted the fingerprints on the cup. Then we used tape to transfer it to paper. There are 3 types of fingerprints. Arches, which occur in 5% of fingerprints, which are ridges that run from one side to the other. Loops, which occur in 60 to 70% of fingerprints. One or more of the ridges enters on either side of their impression. And whorls, which occur in about 25% to 35% of fingerprints. Some ridges make a turn.
We then tried to figure out what who this fingerprint was made by, and we found out that it was Dr. Smart.